Tanessa. Thank you. All right, everybody, welcome to another Tuesday afternoon. We'll be talking more about Arduinos. What I have here that you're seeing actually on the big screen is what we're going to be talking about, and on the video is actually some devices that we're going to be also discussing in this session. So what we're going to basically do is see if you guys had any questions from the previous session. See if there talk about some other types of embedded devices, because this is just an introduction course, and what I'm hoping to do is do an intermediate and advanced course in the future where we do things like connecting to the internet and sending data over the internet and graphing that and all those kinds of cool stuff. Specifically today, we're actually going to be working on something called resistors. And resistors are very, very important in circuit design and electronics. They play a very important role in protecting circuits and other kinds of really neat facilities that they offer. And without resistors, things would be a lot more difficult in building the kind of stuff that we want to do. And we're going to do a little bit of math. Sorry about that, but we're going to be talking about Ohm's law. And we're going to do two circuits today. We're going to work on something, building a potentiometer and a photoresistor. And in between that, I'm actually going to be talking about something called analog signals and digital signals. So with that said, any questions? This is going to be a small chat window. Tanessa, you may need to help me because I have too many windows open and I can't even find my chat at the moment. But if there are any questions, you are welcome to put it in the chat window. Okay, I finally got the chat window. From the previous session. This is something that I'll probably start doing before every session, every module. So of course, you can always email me in between, but if there's anything in particular, I'll give you guys a minute or two to type in. If I don't see anything come in, then I will go ahead and continue. Alrighty, no questions being typed. Of course, you can also ask while this is going on, and Tanessa will be helping me along and catching me to answer some of those questions. So let's go on. So what are some other embedded devices? Now I'm going to stop sharing my screen so you can actually see on the big screen some things that I have here. If you came into our room here where we have all kinds of cool stuff at my house, you'd see all kinds of electronics stuff. So of course, everyone is familiar with our popular red board, right? This is the Arduino Uno board that we've been using. Of course, I have a slightly different variant, which looks blue because I'm using a cheap brand, but this is the one that if I was going to build something, I would be using this for most of my projects because it's actually built really well. I don't want to risk burning it out, so I'm not actually using this during the class. However, there's all kinds of other really cool devices. These particular are embedded devices that use a chip from a company called Espressif. It's specifically, it says here, if you look at the words, ESP32. And the ESP32, let me use right there, you can see the ESP32, ESP32, and upside down over there, but it's an ESP32, is a type of chip that actually has Wi-Fi capability. In fact, you can't really see it, but right over here, these things, this is actually a Wi-Fi antenna that's built into the chip. And on some of these things, let me see if this is one of them. That one isn't one. Here's one where it's a little bit more visible. The Wi-Fi antenna actually looks like it's actually on the circuit board. The really cool thing about this is that this little chip here can be programmed just like an Arduino, but in addition to things like what we'll be doing, turning LEDs on and off, it can actually send signals and data over the internet using this little Wi-Fi antenna. This one actually has an embedded camera right there, and this one actually has a little LED display. And then if I take those away, this is from a company called M5 Stack, and what's really cool, let me see if I can turn it on. This actually has a circuit board right here that's usable for displaying things, and it actually has connectors right there and right there. And I actually have a temperature sensor connected in here. This is sort of like better for when you're doing classes that are for kids, because there aren't too many sharp objects or stuff along that's in this kit, and all kinds of sensors can be built into it or added to it. We will be today talking about these things called resistors, and something called potentiometers, which are these things, and we'll also be talking about photoresistors, which are these things. Let me go back to sharing my screen. All right. So the devices, of course, the presentation will be available for you folks to see. And of course, let me try and get this shrunk smaller. The devices that I was just talking about are from a company called Espressive, which is the ESP platform right here. They make all kinds of really nice embedded boards, and we'll be using this in intermediate and advanced classes. There's another company called Particle, which also makes similar devices. All of these are anywhere in the $5 to $30 range, so still within the range of what we can afford on a day-to-day basis, and even if we burn it, it doesn't really matter. But they offer a very important feature, which is internet connectivity. So we're going to be talking about resistors, which are these little guys right here. I've got tons of little resistors over here. And so what is a resistor? A resistor's job is basically, it resists the flow of electrical energy across it. It does this by slowing the flow of electrons. And by slowing it down, it lowers what's called the voltage. And we'll talk about that as well in a minute. And it does this by actually using different materials within the little resistor device itself. So if you look over here, this is a zoomed um, picture of a resistor. Inside here, it actually has materials that it's using to basically slow down the flow of electricity across it. Usually that's done by winding a bunch of wires inside that little thing. There's a bunch of wires that are wound down, and I'll actually show a picture of that shortly. Now, resistance, like I said, is very important in the digital world. They are used to protect circuits. They're also used in some cases to dissipate energy, usually in the form of heat. And they can control electrical flow to control devices themselves, like light bulbs or motors. So you could control the brightness of a bulb or the speed of a motor. And they're also used in sensors. For example, you actually use a resistor, and the amount of voltage that a resistor drops something by can be used to measure light or temperature, humidity, or even force and direction. When you look at your smartphone, there's a little device in there that can actually tell whether the phone is pointed up, down, or sideways, and whatever. There are different types of devices that can measure that. One of those is actually a type of resistance circuit. You can do it either via capacitance or resistance, but in this, resistors can do that same job. They're all over the place, and they're very common in electrical circuits, and they play a very important role along with other types of components, such as capacitors, diodes, transistors, something called inductors. And whenever you're building a circuit, you'll always end up using a resistor in some form or fashion. And they are part of what we call the core building blocks. They together create other types of devices that we'll also be looking at, including microcontrollers, integrated circuits, transformers, relays, switches, motors, fuses, crystals, and even batteries. A good example of a microcontroller, which is what we've been using, is actually the Arduino itself. The Arduino, it has something called an Atmel Mega 8 microcontroller built into it, and it is itself internally built out of different types of components, electrical components. So what type of resistors are there? There are two main types that we'll come across. One called the PTH, or plate through hole resistor, that you see on the left-hand side. This is the most common one, and if you look on circuit boards, you'll often see these. And then there's another type called surface mount device, or SMT resistors. And those are very, very small. It's called surface mount because they're literally mounted on the surface of a circuit board and soldered on there. And in this example, you can see on our Arduino, there are actually these little devices that form that's an actual resistor. So this big guy over here, which is usually about 3 to 4 millimeters, drops down to about 1, maybe 1.5 millimeters over here. And this is another type of resistor. This is a slightly bigger surface-mounted resistor. It's obviously bigger because it needs to probably resist more electricity. It's actually part of a circuit board that measures electrical current. And so you need a big resistor to measure higher currents. Here's another one over there. And here's a resistor where I've scratched off the plating itself. And if you look carefully, there's actually what looks like a wound up wire in there. And that wound up wire over here, which a resistor with a higher resistance value, meaning it can resist more electricity, has more wires wound about it. Resistors are represented using something called circuit symbols. They're usually represented like this jaggy sawtooth, or using a little square with some numbers around it. What are these things? These are circuit symbols. And circuit symbols come in very, very important when we talk about electronic schematics. Now, don't get scared by this. This isn't, it might look like something very confusing, but as you go through this course, a lot of this will start making sense. In fact, I'll explain some of this before the end of the class. This is actually the schematic or the diagram of how the Arduino Uno is built. And there are lots of confusing, looks like symbols and stuff over here. But what I'm really looking for is something that looks a little bit like a resistor symbol. And remember, I told you a resistor can either look like this sawtooth or this square. And guess what? There's a resistor there. There's a resistor there. Let's look around some more resistors over here. So you can kind of at least start making sense about like, oh yeah, I can see some of these things. Just like a map. This is a very good diagram of how the Arduino works. The reason, by the way, this schematic is available is because the Arduino hardware platform is actually open sourced hardware. It's built, and that's what allows other people to replicate the design of the Arduino and be able to sell their own copies of it. If you're interested, of course, this presentation will be available on the GitHub page. You can actually look at the schematics and the diagrams of it. There's a great link, and I've included in this as well, which talks about the Arduino board and actually goes through in detail what all these little parts. Some of these are very obvious. They're like LEDs that turn on and off, but others might be a little bit more complicated to understand. For example, this is something that converts voltage. It actually has a little bit of metal here to dissipate heat. And this page is a great introduction to the Arduino itself. Switching back. And these are, I wanted to put this in here. These are, for those of you who are interested in electronics and really looking at growing, when you're talking about understanding and building your own circuits, you really need some basic understanding of electronics and how to put different pieces together. And these are 3 great books. One on how to read schematics, obviously. This is a great, Make Electronics is a great book on how to grow from where we are. It actually talks about building more complicated circuits. You can see there's a breadboard over here with some LEDs and some integrated circuits in there. Look, there's even a resistor over there, pointed out. And then as you're more advanced, there is this book called Practical Electronics for Inventors. The 4th edition just came out, I think, a year or 2 ago. Great book for more advanced. All available on Amazon, links below. So something that I got to talk about is a little bit of math. So we've talked about voltage, where we send some electricity across a circuit in order to light up an LED. Well, what exactly is voltage? Voltage is current multiplied by resistance. Well, that doesn't help much. What is current and what is resistance? A good way a lot of people use to explain this is actually using water. Think of water or the flow of water, right? When you have, in this example here, it's actually water that's in a little container over here. This water has a certain amount of energy it has as it's flowing through a pipe. Now, the resistance in this example is the thickness or thinness, depending on how you look at it, of the pipe. If the pipe is smaller, the speed of the water has to increase because the amount of water is less, and vice versa over here. So as you have more water going through, you can either increase its speed by decreasing the resistance, or increase the resistance and decreasing the speed. Now, one way you can look at it is the total amount of energy, which is here depicted as, or energy, in this case, a volt, 1 volt, the amount of current, which in this case is shown as amps, and the amount of resistance, which is in this case depicted as ohms. And we'll go over ohms in just a minute, but just take it as the Greek letter ohm. And the equation called Ohm's law is voltage equals current times resistance. So if you have a certain amount of current flow of electrons and a certain amount of resistance, you can calculate the voltage. Now, why is this important? Because in order to protect your circuits, you need to make sure that you don't burn out any electronics in it. So a good example is what we all know as a 9-volt battery. Now, a 9-volt battery is these guys right here. I'm just going to put it in the camera. Everybody knows what those are, right? It says right there, 9 volts. Well, it's maybe a little shiny there, 9 volts. So this battery can generate 9 volts of energy. Now, do we want to send 9 volts across a LED? This LED has a certain amount of, let me put that down there, a certain amount of current that can go through it before it actually burns out. Think of like a fuse, right? A fuse burns out if you send too much energy through it, like an electrical surge or a lightning surge. So using Ohm's law, I happen to know, and I can look up the specifications for an LED, that I can only run 20 milliamps of current through an LED. Well, if I can only run 20 milliamps of energy and I have a 9-volt circuit, then if I'm not careful and I don't have much resistance, I could really blow an LED out. So going back to Ohm's law, voltage equals current times resistance. I'm going to take this. I know my voltage is 9 volts. I know my current, which is 20 milliamps. So I need to calculate my resistance. Now, if I didn't connect anything between the battery and the the LED, my resistance would be very, 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 very small. In this case, I'm just going to use 0.001. If I just move things around here, I can calculate what my current would be. My current would be some really, really large number. So I would send a huge amount of current through a very tiny LED, which would burn an LED. In fact, if I connected this LED up to this and try to connect it, this LED would burn out. So to protect it, what we do is we use a resistor. The resistor's job is to slow down, to lower the voltage across it. So I know what my voltage is. I know how much current I can send across it, so I can calculate my resistance. So I can do 9 divided by 0.018. This is actually supposed to be 0.018, not 0.018. And I know that that's, yeah.
We just got a message that they can't
Yep.
see the that.
Oh, okay. Can you see it now in the screen? It's this.
Because the power right now, so if you could just make your video bigger so they
yeah,
can see.
Yeah. Let me stop sharing my screen for a second. Okay. Does that make it bigger?
Yes.
Okay, good. Okay, so let's go back over here. So here's my 9-volt battery, and here's my LED, right? By the way, 9-volt battery actually has a positive right there and a negative right there. So I can actually, if I did this, if I connected this together, I'd blow my LED. And I actually tested it before. It does blow. It doesn't release smoke, but it just stops working. So if I connected those two, there's no resistance to stop all this energy going into this little LED bulb, right? The bulb is designed to work around anywhere from 2 to 3 volts of electricity. So what I would need to do is actually put a resistor in between. but what size resistor do I need? Do I need to put something that can stop a lot of electricity or a little bit of electricity? And resistors, we'll see in just a minute, come at different ratings. Going to go back to my screen. And so the resistance can actually be calculated. And in this case, it's going to be around 500 ohms. And when we talk about resistors, they actually come in different ratings. And this case, we're going to use something called 560 ohm resistor. The examples that we'll be using in our class will actually be using 330 ohms because there's a nice variation because an LED light can work on many different volts. Of course, not too high, but the goal of the resistor here is primarily to make sure that the voltage is dropped low enough that it won't burn the circuit or burn the component, in this case an LED. One of the things that this is explained much more in detail in the Sparkfun tutorial that's part of the course, and I put a link for it in this as well. So these, the ones that I've shown you so far are called fixed resistors, meaning they always lower the voltage by a certain amount. A potentiometer, which is what we'll be using in this class for today, is a variable resistor. By using a knob, you can actually vary the amount of resistance, and thus you can control the amount of voltage on it. So I'm going to stop sharing my screen again, and give me a second. In our class today, we're going to be using this guy. Hope you can all see him. It's a potentiometer, a pot. There's also a different way, another one that looks like it, but this one's, they don't come with the kit, but here's a different potentiometer. This thing that looks like an arrow, let me make sure I get it underneath there, can actually be turned. You can use your fingers to turn it, or in this case, I'm using a screwdriver. And this actually controls the amount of resistance. And this one over here, I can actually use that to turn. And this controls the amount of resistance or the flow of electrons through it. Why is this important? Well, you probably have seen these things. If you've ever seen a volume control on a radio, for example, that's what that is. Behind that knob is an actual potentiometer. Of course, there are different ways of doing it now. Digital circuits don't actually use resistors, but in the old days, back when we had radios, those what those things were behind it. 1 minute while I start sharing my screen again. So let's go ahead and build this circuit. So for those of you who are following along in the class, right, we're actually going to circuit 2 over here, potentiometer. That's what we're building. We're going to build that and this as well. And now, if you haven't done this, I know I've jumped ahead in some cases, but I was hoping you would, after the classes, you've actually gone through and try to build some of these circuits. Give me a second while I get myself set up over here and clean up my table to work on this. All right, so I'm going to stop sharing my screen. I'll zoom up this in just a minute once I've just gone through this. So in every one of these sessions here, these circuits here, you'll always see the parts that you need. In this case, the breadboard, the red board, which is the Arduino itself, LED, that's right there, a resistor, and in the kit that we bought, there are 2 types of resistors. One that says 10K, and another one second, that says 330. And I will zoom this in just a minute so you guys can see it better. Some jumper wires, which are these little guys over here. And of course, the pod itself right there, that blue device, right? So you always kind of get all your parts together before you build it. And then you go down, scroll down a little bit, read about what the class is about. And of course, I'm basically going over this in my notes. And then over here is how you actually build it. And so one of the cool things about this is that if you can't see this, you can always click on this. It zooms it up nice and big so you can kind of see the wiring. I'm going to go back. And I'm actually going to take this apart so that you can see me build this from scratch. What we're doing, let me demo it before we show it. Okay, you can see that blinking, and I'm going to stop sharing my screen now. Okay, hopefully you see that little LED blinking. And oh, I forgot to connect my potentiometer back. I took it out of the circuit. Give me just a minute. Good thing all the stuff is low voltage DC. Okay, so you can see that LED blinking. And what you can actually do is control the blinking rate. And you can see it's now very, very slow, the blinking. Blink off, blink off. Or you can speed it up. There we go. Wow, it's blinking really fast. Let me slow it down a little bit. There we go. So that's what we're building. It's the blinking light, but just controlling it a little bit more. Okay, I'm just going to turn off my power to my Arduino so I can take this apart. And we're going to build this one from scratch. Well, almost from scratch. I'm just going to leave a couple of things in there so it's a little bit easier to see. So in the presentation, it's in the activity guide. I'm sorry, not the presentation. You can see the start sharing my screen again. 1 minute. You can see the cabling or the wiring diagram that's over here. And so what I'm going to do is basically follow this wiring diagram and wire this circuit up in parallel on the circuit board itself. Now I'm going to zoom onto the board so that you can see me connect it. So I can't do both at the same time. So either I show you the video or I show you my screen. I rather show you the video because you can always load this yourself and look at it. And I think it's more important for you to see me wire it. So what I'm going to do is basically wire the 5 volt, which is a red ground over here, along with the yellow, which is the signal to turn that to blink the LED just like before, as well as wiring up the potentiometer, the resistor over here. And while I'm doing that, I'm going to show you some things about the circuit board that's very important to understand. All right, so let's go ahead and stop sharing. And I'm going to bring that over here. Okay, so hopefully all of you can see the board. So the first thing that I'm going to do is actually connect up using the red and black wires right here, jumper wires. Now, usually you use red to represent positive or voltage. So in this case, I'm going to connect up that to 5 volts. I apologize if it looks like it's off. It's not off. It's just because of the angle that this is coming in. But I have this actually connected to the 5 volt wire. And I'm going to connect this up over here and explain this part of the circuit board in just a minute. And then I'm going to connect ground, usually represented as black, over here. Okay. So remember, so what this does is this can generate 5 volts of electricity, just like a battery. And this is the negative part of it, or ground. And when you connect it here, that power is available across all of these pins, these holes in here. So that's why you see this little positive. 1 second, let me move this over a bit. That's why you see this little positive and negative over there. So normally you connect up. So this is kind of what's called a power bus. You can get your electricity to your devices from this. Just going to move it back over here so we can focus on parts we're interested in. And so the next thing that in the diagram that it tells me to do is wire up the LED. So let me go find my LED. Oh, my LED is already in here. I forgot about that. So I'm going to connect up. It says go ahead and connect up black to the positive and negative. Remember I told you in an LED there is the positive is the longer one and negative is the, or ground is the shorter one. So I'm just going to put that in there. I'm just going to point it down so you guys can see it being wired up. And connect up ground right there. And before I can connect up the data or the thing to turn that on, I need to protect this LED. And to protect the LED, it says use a 330 ohm resistor. So I am going to put that, I'm actually going to move this up a little bit so I get a few more pin spaces right here. Does that make it better? Connect up the resistor. There. And then I'm going to use the yellow wire. The coloring for the, obviously the coloring, wires are wires. The coloring helps you understand where things go. And I'm going to plug that into pin 13 right there. So just to make sure you understand the circuit flow, here is the current going across, electricity, going up through the resistor, coming down here, going through the LED, which will make it light up. And then the circuit goes back and connects back to ground back there. So even though it looks like a mishmash of wires, there's actually a single circuit going across. All right, so that's wiring up the LED so it can turn on and off. Now we have to wire up the variable resistor or potentiometer right here. So I have it over here, and it says to wire up my ground. Sorry, my 5 volts, and I'm actually going to do this before I can see it because it's hard to see this part right here. If you look carefully, there are 3 wires, 3, and if I'm not careful, I can be shifted off by a little bit too much, left or right. So I want to make sure that I connect it just right over there. So I know that I'm going to use these 3 lines, so I'm actually going to use, see right here it says 20. I'm going to use that as my baseline. And I'm going to connect my ground. And then the last one I need is the blue, which goes to A0, which is right there. Hopefully I can reach it. Move it down a little bit so I get a little bit of space. A0. And we'll go over the wiring again, and then I'm going to connect up my potentiometer right there. So in this case, here's my current coming in. I'm closing the circuit, but the part that I want to read is the value of this resistor, and I'm actually doing that by connecting up the blue line up into a pin called A0. And we'll see why it's called A in just a minute, because it's an actual analog signal. We'll talk about analog signals in just a minute, but that's the wiring. Everything looks good. Let me actually turn it on. It's working already. Why? Because I already happen to have programmed the circuit before, although it's not supposed to blink that fast. There we go. Let me switch back and share my screen again so you guys can see the code. Okay, and so here's the code right here. Most of this should look very simple, just like before. I'm not going to go over the setup because we've done it before. The most important part right here is actually this. This is called analog read. And if you look there, it's telling you the pin A0. A0 is where we plug the blue wire in. And this is reading the value of the resistor, the potentiometer, and what its value would be. Now, it's a value that's between 0 and 1023 because the Arduino takes a voltage and converts it to a value that we can read. It's not going to actually tell you it's 3 volts or 4 volts. It's not capable of doing that. It's instead going to give you something that it knows about using the binary system. And in this case, it happens to be a 10-bit binary system, and 10 bits means that it can read have up to 1024 different values. What it's doing is basically taking that value and using it as a delay. A delay meaning whatever value it reads, it's going to pause for that long. And so if we have a higher resistance, then it's going to turn the LED off for a longer period. If we have a lower resistance, it's going to turn the LED off for a shorter distance. And so it looks like it's blinking slow or fast. So I did wire this correctly. There it is. It's blinking slow. Or it's blinking fast. Okay, I'm going to turn that off so it's not so irritating. All right. Now I'm going to show this. I built this circuit also in the Tinkercad, and I'm just going to show. If you guys haven't played with Tinkercad Circuit Designer, it's really cool. And the reason I did that is because I wanted to show an example of what's actually happening from the voltage itself. So let's take a look at this. Right here, I actually have a multimeter, which is measuring the voltage. I'm going to change this, and you can see as I'm rotating the potentiometer, I can actually control the voltage. Now, this voltage is being read in A0 as a value, and it's being used to control how fast this LED light blinks. Over here are something called oscilloscopes, and I'll be talking about that in a future class. But by changing this, remember that I'm changing the voltage over time. So while the multimeter can show me a specific voltage, an oscilloscope can tell me the voltage change over time. And that's really useful when you're designing circuits that are bigger, trying to see what happens at a certain, because something changed in what it's measuring. Let me stop my simulation. Okay, so one of the things that I pointed out in the example that was over there was this right here. This is the voltage that is being sent out of the potentiometer. Over here are two voltages, one being the voltage before the resistor and the other being the voltage after the resistor. Remember that the resistor lowers the voltage. So even though I'm sending almost 5 volts through here, after the resistor, when I measure it, that voltage is much, much, much less because the resistor slows and lowers the voltage. All right, so we did something that I didn't cover, but I want to cover now, which is what is analog versus digital. Analog signals are very common in the world around you. In fact, in the previous example, I actually happen to have a picture of an analog signal. Temperature. Temperature varies over time. Sound, light, TV signals until 2009 when we switched to digital signals. All these are examples of analog signals. We live in an analog world and we don't realize it, but the most common way to think of an analog signal is it can have an infinite number of values, right? If you look at temperature, even though you might say, oh, it's 98 degrees outside, well, it's not really 98. It's probably 98.1, or it could be 98.101. The range in temperature could be an infinite number of values. Digital signals, however, are what's known as discrete, meaning they have a fixed set of values. Some people call them states. In computers are digital, and that's because they have most likely representations using what's called binary, or 0 and 1. And we use that same way to represent voltage. For example, we can say voltage of 0 represents a 0, and voltage of 5 volts, could represent a 1. Most often we have a little bit of variation, like 0 volts to 1.5 volts means 0, and anything about 1.5 means 1. And there are some examples of discrete or digital devices in our world. For example, on-off switches, locks, stoplights, right? If you're at a stoplight, it's either red or green. It's not usually both at the same time unless something's wrong with it. Another example that might be really easy to understand is, if you've ever seen one of these things, let me switch to my, it's probably too big to see. All right, what is this thing? I'm going to turn it on. I hope you guys can hear it. This is actually a sound machine, right? It's actually a white noise generator. But what it is basically a fan inside with these little holes that control the type of noise that's made through it. What people use this to sleep, right? Mostly people who have kids use this either to put kids to sleep or to drown out the noise of kids sleeping, trying to get to sleep. Now, this is an analog device because there's an actual fan in there, and the noise coming out of it is made by these fans going through these holes. Well, if you have an iPad, hold on a second. Here is my iPad. I don't know if you guys can hear it, but this is a white noise machine generator in an app, right? This is not being made as an analog signal. This is actually an app that's generating noise through the digital speaker of my iPad. And that's an example of an analog versus digital signal, but doing the same thing, but using different types of technologies. Give me a second while I share my screen again. I'm going to skip this, but I'll come back to it in a future session, but I wanted to make sure it's in there. The Arduino has the ability to measure analog signals using what's called an analog to digital converter. And you just have to understand that it can get anywhere from 0 to 1024 different values. There are actually 4 analog to digital pins that can measure 5 analog to digital pins right here on the left-hand side that can be used to measure analog signals. What an analog to digital converter actually does is it takes an analog signal and converts it into a discrete value. So for example, if you're measuring a value that happens to be close to 5, it most likely will pick 5. It can't measure it as 5.5 or 5.7. It'll just come to the closest approximation. And you can take an analog signal, this one looks like a sine wave, and convert it into discrete values that look like these bar charts. Each has a discrete value. It jumps up or down. And you can also convert digital to analog, by the way, and that's how a lot of the original music, like when you're playing MP3 files through your headphones, you're taking a digital data and playing it out through an analog device like a headset. Now, in the Arduino, remember that circuit diagram we looked at a while ago? Well, here it is, right here. The Arduino has the analog to digital converter as 5 pins. That's right here. If you remember, we found some resistors. Here's a resistor over there. There's a resistor over there. There's a resistor over there. Well, now we understand a few more things. So understanding these schematics as you learn more and more about electronics becomes easier, especially when you're trying to identify things. All right, so the second thing that we want to build is what's called a photoresistor. Give me a second while I tighten some bolts here. Okay, a photoresistor is very similar to a potentiometer, except rather than using a knob to control the resistance, it uses light. And you can see this picture over here, light hits this photoresistor component, and by the amount of light that's going in there, it can control the amount of electricity that goes through it. So let's build the same circuit, except we're going to use a photoresistor. Now I did this because in this way so that you could see something very simple. It's actually, I'm going to go up a few cells. This top part over here is exactly the same. Down here, it's almost the same. Notice the black, the red, the black, and the blue. Well, we still have the red, the black, and the blue, except instead of a variable resistor or a potentiometer in there, we have a photoresistor in here. So to build that is actually very simple because we just need to swap out a few components. Give me a second while I stop sharing my screen. There we go. Now you can see the zoomed screen. All I'm going to do is take this guy out, find my photoresistor in the mess of a table here. And the photoresistor is connected between the red and the blue. The red and the blue. And then there's a little resistor that's connecting between the blue and the black. And be sure to look at what resistor you're supposed to use in the tutorial from Sparkfun. So let me move that out of the way so you can see it. So between the blue and the red, we have that connected, and between the blue and the black, we have the resistor. This resistor is there just to create, to complete the circuit using something called a voltage divider, and we'll talk about that in another session. But the purpose of this is really to understand this guy and see how this guy will slow the voltage across this, or lower the voltage across this, and not slow it down. Slow the flow of electrons. Make sure the wires don't touch. Okay, now I'm going to load up my Arduino. Okay, here's the code that was written over there. If you look at it, it looks very similar to the other value, except to the other code, except it's reading the value of the analog A0, the analog pin, and then depending on what's called a threshold, it's either going to turn the LED on or off. Now this is very important. We're not going to blink the LED. We're going to turn the LED on or off. So it's almost like a night light, which is the example that they're basically building in this. So let's go ahead and upload this. First, I'm going to turn on my potentiometer. Okay, now it's still blinking because it's just using whatever value it has that's coming through here to run that. Let me go ahead and upload the code. Now we're going to use this also. I showed this. Oh, I forgot to connect my port. Tools. Choose my port. I do have my port there. And let's try uploading it again. There we go. Oh, now this happens every once in a while because I've been unplugging and plugging in my Arduino, and so it may have gotten a little bit wonky. And so sometimes I just do it a few times, and there we go. It finished uploading it. All right. So I'm going to add, we saw this in the previous class, the serial monitor over here. And if you look carefully at the code over here, there is a serial.println photoresistor. So what is this doing? This is taking the value of this variable, which it got from reading the A0 pin, and then printing that value out. So let's take a look at this. Right now, you can see that it's printing a value of 800. I'm going to put my finger over it. Now you can see that it dropped down to a value of 300. I'll take my finger off. So this is increasing or decreasing the resistance by the amount of light that comes in. So when there's no light, the resistance is lower. When there's a lot of light, the resistance is higher. Now, why is it not blinking the LED on or off? Well, let's take a look at our code. The threshold I put here was if the resistor value is less than a certain threshold, then turn it high, meaning turn on the LED. Well, my threshold is 150, but in this current example, the lowest value I get to is 330. So it's never going to turn it on. Let's change that value. Let's say if you drop more than 450. Let's go ahead and upload the code. Okay. Voila. There we go. Block the light, turn it on. Right? And take a look at the value on my screen. It's 350. Right? So why was this different? I happen to have run this test when my when my overhead LED light was on, and different values I was experimenting with different values depending on changing the resistance of the other resistor. But that's a simple circuit. And one really cool thing about this is we're using an if statement here. If you remember the previous class, we're using a conditional clause here. If the value that we read is less than a certain threshold, which in this case is 450, then we do this. Otherwise, we do that, which is to turn it off. Okay. I'm still sharing my screen. Good. All right, we're coming to the end here, and surprise, you guys have some homework. If you haven't been building the circuits, please do build them. The best way to learn this is definitely by experimenting and playing with it. In fact, if you look at the activity guide, at the end of it, they actually ask you to do a couple of, let me get down there, a couple of things to change things around and seeing if you can do it, if you can solve the challenge that they've given. I highly recommend doing that. And if you can't do it, send me your code and ask me why it doesn't work, and we'll try and work through it. The best way to do is to challenge yourself to try and go and see why it's not working. Definitely also make sure you can get here's my Arduino, that you can get the serial port values, because that's how you can tell if something's right or wrong. So for example, I'm purposely going to make a mistake. I am going to disconnect my photoresistor. See that value? It's printing 0 all the time. And so if I put my photoresistor back in, hopefully in the right ports, the value comes back in. Okay, so without the debug information, that would have been really hard to figure out. So knowing how to print into your serial port and see what these values are really, really important. And I think last time I mentioned, make sure your baud rate matches. For example, in this one, it says 9600 baud. That matches the serial.begin right there, that it says 9600. Okay, switching back. Definitely, if you have a chance, study the pinout guide and understand what makes an Arduino an Arduino. All of these pins that are on the, 1 second, let me move this over a bit. All of these pins that you see over here and over here do certain things. Each of them has its own unique purpose, and it's good to start understanding what those are. I've jumped and covered a couple of things that are important, but they're not needed for doing this session. But it is important that you kind of go back and review some of the things I've talked about. The engineering essentials right here is a great page, because it kind of goes over the different parts of electricity, including what is power, what is a voltage, what is a circuit, what is resistors, what's a multimeter, breadboards. We'll talk about oscilloscopes in a later class, but it's good for you to become familiar with some of these terminologies so that when we come across it, you'll at least have an idea of what it is. This is an extra credit. You can try and do it. This is my own challenge. You can use the potentiometer to also connect to a digital pin instead to see what analog value makes the digital value go from 0 to 1. Remember what I was telling you, that a digital means either 0 or 1 depending on the voltage? Well, what actual voltage value does it make it go from 0 to 1? And you can try and extrapolate by trying to see what number between 0 and 1023 makes the digital value go from 0 to 1 using digital read, and see if you can extrapolate what the analog value is. I'm not going to explain what this is, but I'll give you the solution in the next class so you can understand what extrapolation means. Okay. And we're at the end of the class, I believe. Yep. And once again, I will upload the latest copy of the notes to my GitHub page. Here's my email. So please definitely, the code are also there. Of course, the code is also available on the Sparkfun page. But as I build these things, you'll see more and more of these being applied in there. And we're also uploading the videos, the link to the videos here as well. But it's also available at the FAU Libraries YouTube page. So we have a few minutes for questions. If anybody has any questions, I can answer them. No, doesn't look like it. Well, have fun building this. Don't burn down the house. And if you have questions, please email me. And next session, we'll be working on the next 2 circuits, as well as answering any questions on this one and going over the challenge that I wrote. Okay. Well, thank you, everyone. And talk to you guys soon. Take care. Bye. Thanks, Vanessa.